I recorded yesterday too. All right, so when we discuss the idea of theoretical for probability, you guys kind of touched base off of it yesterday. Everything that you were doing yesterday was theoretical probability. When we flipped the coin, you were identifying the fact that, hey, if it lands on tails, that was going to happen half the time. Does it always happen half the time, though? So if I were to flip the coin 10 times, am I guaranteed that I'm going to land on heads 5 and tails 5?
No.
No. That's why it's called theoretical. In theory, this is what should happen. So that's what I want you guys to write down right now. That with theoretical probability, we indicate this as what should happen. That's a really important thing. It's what should happen. And what's also very important for you to understand is that this probability never changes. The probability of flipping a coin, a single coin, and landing on heads is always going to be 1/2. The probability of rolling the die and landing on a 4 is always going to be 1/6. That will never change. The way that we find our theoretical probability is we identify the number of favorable outcomes. So basically, what outcomes, or how often does an outcome that we're looking for occur, out of the total number of outcomes. That's our theoretical probability. So like I stated before, the probability of landing on tails. Tails being the favorable outcome occurs only 1 time on a coin out of 2 whole times, or 2 whole outcomes that a coin has. The probability of rolling a number 4, the number 4 occurs only 1 whole time on the die out of a total of 6 numbers on that cube. Okay, so that's the idea of theoretical probability. In theory, this is what's supposed to occur, but it doesn't always happen that way. Experimental probability is different. With experimental probability, this is what actually happens. So like I said, if I flip the coin 10 times, it might not land on heads 5 times. Maybe it's going to land on heads 2 times. And tails 6 times, or sorry, 8 times. So what actually happens is when you're performing an experiment. So there has to be action with an experiment. And an experimental probability, that probability is constantly changing. Okay, if Richard flips a coin 10 times, the results that he gets isn't going to be the same thing if Allison flips it 10 times. Maybe Richard lands on heads every single time and Allison lands on heads twice. But they both perform the exact same experiment for the exact amount of times, but the results are different. So your experimental probability is always going to be changing. So make sure you write that down. This probability is always changing. Thank you. Thank you. Okay, for experimental probability, the way that we identify it, it's the number of times an event occurs. This is my orange, by the way, in case you don't know what color that is. Number of times the event occurs over the total number of trials. Who can remind us, what does trials mean? Raise your hand to tell me. Yesterday we talked about it. When I say trials, what am I indicating? Vincent? Huh? Tests, like how many times are you doing it, right? How many flips, how many rolls? Vincent, what's your house? Ravenclaw? Okay. All right, so if I were to go ahead and flip a coin 30 times, and it lands on tails 7 times, then the experimental probability here of flipping tails is going to be what? How many times did the event I'm looking for occur? Not 50%. How many times did tails occur? 7 times. It occurs 7 times out of how many total trials? 30 trials. So it's 7 over 30. All right. We got a 3-section spinner of equal size. That means that each of the sections is the same measurement. 1/3, 1/3, 1/3. And then these are the results. All right. So the first thing that I want to know is I want to know the theoretical probability of landing on pink. So theoretical probability is not based off of the experiment, is it? There's no action occurring. So when I'm talking about theoretical probability, I have to focus on the spinner, not on the action. Does that make sense? So do I have a picture of the spinner here?
No.
No. Can I create one?
Yes.
Yeah. How many sections?
3.
And they're all equal size, right?
Yes.
So just draw yourself a circle and split it up into 3 little sections. Okay, I know that one of them is going to be blue. One of them is going to be green. And one of them is going to be pink. There, I've just drawn my spinner. So the theoretical probability is based off of the spinner. What's the probability of landing on pink? 1/3. Pink occurs 1 time out of 3. So it's 1/3. Now, if I want the experimental probability of pink, that's based off of the actual experiment. How many times did pink occur in my experiment? Emiliano? Huh? How often did pink occur in my experiment? Look at the chart. What does pink go up to? 15. So it occurs 15 times out of how much total? How do we find the total? Add them all together, right? 10 plus 15 plus 5. What is that going to give us? 30. Okay, so it's going to be 15 out of 30. Don't forget that you should always simplify it. So 15 over 30 simplifies to 1 over 2. So half the time the experiment landed on pink. Are those the same?
Yes.
1/3 and 1/2 are the same?
Oh, no.
No. Okay, so your theoretical probability and your experimental probability are a bit different from each other. And that's okay. We're going to talk about how to nullify that fact. Which one is greater? 1/2. Okay, sometimes they're going to be asking you to make a comparison. So you might indicate, oh, my experimental probability is greater than my theoretical probability. Okay? Let's go ahead and do another example. Again, this will be located online tonight if you need to go back to it. Okay? Yes.
What if we have more space? Do we still have to clear page 8?
You're going to want your page to be the same as mine. Okay, frequency table indicates how many times a specific event occurred utilizing tally marks. Okay, so if I'm numbering it 1 through 6, what kind of event do you think I'm doing? Or what kind of experiment do you think I'm doing? A die. Good. So for here, I'm stating, hey, we're going to go ahead and land on a 1 7 different times. I landed on a 2 3 different times. I landed on a 3 3 different times. Landed on a 4 5 times. Landed on a 5 twice. And landed on a 6 12 times. Okay, so I want to go ahead and identify the theoretical and the experimental probability of rolling a 6. So again, for theoretical probability, I don't need the table. I need to know what? If it's theoretical probability, I'm focusing on what? Vincent? How many numbers are on the what? On the die. So this is only the experiment. This is the results of the experiment. That's for experimental probability. For theoretical probability, you're just looking at the actual item. Okay? So I am looking at a die. Okay, so I've got my little number cube there. So I want the theoretical probability of landing on a 6. So how many 6s occur on the number cube?
1 out of 6.
1 out of 6, right? So in theory, I should land on a 6 1/6 of the time. or roughly around 17% of the time. For the experimental probability, my experimental probability of rolling a 6. Now I need to actually look at results. I need to look at how often I performed my experiment. So how many times did I actually land on the 6? 12 times. Out of how much? Out of 32. Good. If you add all of this together, you're going to get 32. So that becomes 12 because we're looking here at the 6. Out of a total of 32. Okay, once again, you should always simplify it, and it would simplify down to 3 over 8, because it's supposed to divisible by 4. Making a comparison, which one's roughly bigger?
3 over 8.
3 over 8, right? This is about, like I said before, this is roughly about 17%. This would be equal to 32.5%. Okay, so our experimental probability is significantly larger. It might not seem like it's a significant difference, but it is. Okay, tomorrow we'll continue discussing theoretical and experimental, and you'll do your assignment in class. Okay? We're also going to talk about a simulation. Go ahead and pack up.